Yes, sir, you can start now.
Okay. So, yeah. So some of the operations on binary search tree is just like for the other data structure or abstract data type, you have the data structure, and along with the data structure, you are associated with some kind of functionalities. So the same thing I will be repeating what I did for other abstract data type, that as these data structures are defined by the user for their own purpose, there is no definition in the compiler itself. For example, in C, you can write int float, F-L-O-A-T. So that implies that the variable that you are using, it is of type integer or it is of type float. But here you are creating your own data structure. Maybe linked list, maybe array, maybe stack, maybe queue. So these data structure are not predefined in the compiler. Its size are not defined. You have to define by yourself for your own purpose. Maybe you may create a tree or stack. Hello? Hello?
Yeah.
So you both of you?
No, okay.
Okay. So you may create your data structure, for example, stack or array or a tree, whatever, for your own purpose that is of different size of nodes. I may be creating my own data structure, maybe array or linked list or queue, whatever, for my own purpose. And associated functionalities may not be exactly same. Okay, so there are some example definitions, operations are given, but for your own purpose, you can create some more operations on it. So for example, search K and T. You are searching a binary search tree with a particular key value, whether that particular key value is there or not. Similarly, for insertion, you want to insert a new node with a value K. K is the new value on the tree T. You want to delete a particular node value with the value is K. You need to search the entire tree and find out the node with the minimum value. You search the entire tree and find out the node with the maximum value. So these are some of the operations that you may do. Okay. So you may you can search a particular node that is key, and that function is like this. So binary search, you are searching the tree, binary search tree with a particular key value. If the root is itself null, then there is no element, so you don't need to search. If the key is equal to root, then the search is found. Else, if the key is less than the root, if the key value is less than the root, that means you have to search the left subtree. Because as I defined at the beginning, for binary search tree, all the nodes in the binary, all the left nodes in the left subtree are less than the root. All the nodes of the right subtree are greater than the root. Okay, so if the key is less than the root, then you search the left subtree. That means you call the same function binary search with the parameter as root left and key. If else part means if it is not greater than, if it is less, if it is not less than, that means if it is greater than, then you have to search the right subtree. So root right and the key. So you are calling the same function bin search with this the pointer and the value. So this way you keep on going. So insertion of a node in binary search tree, you need to find out the proper position and then you have to start, insert it. So for example, you want to insert 4. You want to insert 4. So first you compare 4 with the root node. So 4 is less than the root 5. So the position of 4 must be in the left side of the root. So you go on searching this side, not the right side. Then you compare, do the same operations. 4, search with the root node, that is the root of the subnode, subtree 2. The answer is greater. So you search the right path. Then you go to the 3, compare 3 with 4. The answer is right. Go to the right path. So when you go to the right path, you will get the position 4. So this way, for insertion and deletion in a binary search tree is much easier because you are considering already it is a sorted and sorted in some particular order. So that insertion code is given. So whenever you go for insertion, you need to do malloc function because first you need to reserve the space for the new node. You need to put the values to make the 2 pointer null, and then you find out the appropriate position and make it connected. So for insertion or deletion, you need to readjust the pointer values. First you have to create the node and then you have to adjust its proper position by changing the value of pointer. Similarly, for deleting the binary search tree, first you need to search it, the proper position, and then delete it from just make the pointer value to null. Okay. So these are the codes. I'm not going to the detail of the code. Okay. So this much is all about the binary search tree. So in a nutshell, if we discuss what we studied so far for the last 3-4 days, is we have started with a very fundamental idea of array, then function, then we go for abstract data type, then we discuss linked list, different type of linked list, different operations of linked list, then some of the other data structure using linked list and array, for example, array, for example, stack, queue, different operations on stack and queue. Okay, then we go to the tree. First, we discuss the very fundamental of tree. Then, as tree is also an abstract data type, so what can be the possible operation associated with the tree, and special type of tree, binary search tree, and different applications of tree in computer science. So this much we have discussed. Now, if you need some more thing from me, I can discuss, or if you need a particular topic to be discussed once again, I can again discuss. And if you require the slide, of course, I will share the slides with your teacher. He can share with you. So the slides are associated with the code also. You can try the code in your machine. But as computer science student, you should try the code. But before trying the code, I will request for each and every operations, you first write the pseudocode. Dry run the pseudocode with an example. Then you write the code, C or whatever programming language you use. But don't go directly for writing the code. Code will be, that means the computer code will be coming at the end. Before that, first you try to make some visual representation, maybe the diagram, the pseudocode, the dry run of the program. Take some example, dry run it with a pen and paper, see whether you are satisfied with the result or output or not. Then you go for writing the code. Okay, so that should be the approach to study of data structure. But again, I'll be telling data structure is a very, very fundamental subject of computer science. Okay, very, very fundamental side. And I will really appreciate your principal, your administration, and the teacher, the Department of Computer Science, who have rightly taken this subject as a special class. But I think sometimes I am very unfortunate that I could not take the class in front of you, in front to front, because taking the classes in this virtual mode is really, really tough, really tough. Unless as a teacher, I can interact with the student. As a teacher, I cannot see the faces of the student. Unless I see the faces of the student, I can't understand whether you are with the class or outside the class, whether you are with me or not, whether you are with my discussion or not. So it's a very, very difficult for me to take the classes in this scenario, but still I will appreciate the administration, the Chaivas Engineering College, the principal and the computer science department, that they have rightly taken a very fundamental subjects to teach for the third semester. Because this is a very, very fundamental subject. Based on these subjects, the remaining subjects of computer science are built up, starting from your algorithm, database, computer network, all subjects are based on this particular fundamental subjects. So data structure is being treated as one of the fundamental subjects of computer science. Okay. So if you have any
student, if you have any question, please ask sir. Student, if anyone has any question, please ask sir. Okay, sir. I think it looks like we have covered all of our questions. So, there is anything else you wanted to cover before I wrap up, sir?
Okay, no problem.
Okay. Thank you, sir, for this wonderful session.
Thank you so much.
Thank you for this wonderful session. We hope we will meet again next time.
Yeah, I mean, this taking the classes in this domain is really, really tough.
Yes.
I mean, yeah. So maybe even instead of 5 days, even we can take the classes in 2 days. That will be much more than beneficial if it is a front-to-front class.
Thank you, sir, for this feedback. We will again recheck that, and thank you everyone for this session.
Thank you,
thank you, sir. Thank you, sir.
We're wrapping the session, so I'm ending the meeting.
Okay, bye.
Okay, thank you, sir.